I'm starting this video out the same way I would do it in a class. Now this video, in this section, we're not covering everything about the refrigeration cycle. What I'm going to do is break this down into steps that allow them to be digestible, allow you to start understanding this information, and then we're going to be adding to it in future videos. This is also a video we're going to be following along. So what you're going to need to have is a blank piece of paper, turned sideways, printer paper works the best, and also at least 3 colors, a blue, a red, and a black. So as we come writing on the board behind me, you're not going to be able to see these words. And I do that on purpose. I want you to see that I'm writing this stuff down, and I want you to also write this information down. If you really want to learn HVAC, these are the steps that's going to help get you there. Now when I write these words down, you can always pause the video, back it up, and hear those same words again. And I'm also going to be repeating them over and over because I want you to really get these down. Lots of vocabulary words in HVAC, so let's begin. So we talked earlier about thermodynamics, and we don't create cold, we simply move heat. So we move heat from inside the house and reject that heat outside the house. As I take heat from inside the house, there's less heat, the temperature of the house then starts to drop. That's how we cool the house. We're moving heat from inside to outside. So I'm deciding to make this video focus mainly on residential, and then we're going to add to this. But this refrigeration cycle I'm teaching you, you can apply it to any system that there is. So just to help you start out with residential, most people live in an air-conditioned home, so this helps you understand that concept. This would be our indoor unit. This would be inside the house. Maybe you open up a closet and it's there. It could also be located in a basement, or it could be located in an attic. Now, even though it's in the attic, it's still considered the inside unit. You're going to have ductwork bringing air from the house through this unit and back out into the house. So this would be our indoor unit. And then here's going to be our outdoor unit. This unit's going to be located somewhere on the outside of the house, maybe even on the roof. Now, if we're talking refrigeration, it's going to be outside of a box. You'd have inside of a box and outside of a box. Or refrigerator, inside of a box versus outside of a box. So this is going to be our outdoor unit for residential. So this is where we're rejecting the heat. So we're absorbing the heat out of the house here and rejecting the heat out of the house here. First law of thermodynamics. The second law of thermodynamics is to make that happen, I need to have something cooler than for the heat to go into. So what we're going to do is run refrigerant through an evaporator coil, and that coil is going to be lower than the temperature of the air. So the heat's going to leave the warmer air in the house and go to the cooler refrigerant. Then we're going to have to trick the refrigerant. We're going to have to raise the temperature of the refrigerant to make the refrigerant warmer than the air temperature. So now the heat in the refrigerant is warmer than the air, and it's going to leave and move to the cooler air outside. So to make this happen, we have a few other things to talk about. We have fans in both of these. We're going to pop the cover off of this unit right here, and you get to see exactly inside what we're talking about. Here I have a blower motor. This is pulling air from the house and pushing air back into the house through the duct system. And the lower side, on this particular model, we have our evaporator coil, or indoor coil. So here now we can have access, we can actually see this evaporator coil. So we're pulling air across this evaporator coil and pushing it back into the house. This particular model has the evaporator coil below the blower, but it could also be above the blower. It doesn't matter where it's at in the airflow, as long as we're pulling air, and it's essential that we move air across this coil because we want to take heat out of the air in the house. I put that cooler air back in the house, and I do this until I get the temperature of the house where I want it to be. Outside, we have something very similar. We also have a coil, and what we're doing is making sure this coil is warmer than the air temperature. So this way the heat from the condensing coil wants to leave to the cooler air outside. A lot of steps into making this happen. So we're going to start right here with this video. And what I'm going to start with is the compressor. Every single instructor will start with what they prefer. I prefer starting with the compressor because it's the easiest thing to identify. In this video here, we have the compressor right here. This is a Ream-Rud unit. It's the easiest to film with because their compressor, even though it's inside of the outdoor unit, it is outside of the coil. So here's our condensing coil, and this one's very dirty. But a lot of times you'll see your compressor right here in the middle. But this is our compressor. So we're going to start right there. This is going to be our first notes. So this is what the compressor looks like. What I'm going to do is I'm going to draw the compressor just simply like this. I just do this little half top thing. That's how I draw my compressors. Draw something in your paper towards the top right-hand side. Now we know the word that we learned was compressor, so we're going to write that word in as well, compressor. Now let's assume that you can see my writing. I am the worst speller in the world. I know HVAC, I do not teach English, I do not do writing or grammar. So the words, however they translate for you, compressor. But in HVAC, almost everything has at least 2 words. So the compressor has another word. The other word we're going to call it's called a vapor pump. So it is a compressor. It's also called a vapor pump. Both those words are important, so we're going to interchange those words. So you're going to have to know both words. Now in class, what I have my students do is actually go outside and physically touch the compressors. So we get used to seeing them. We'll also look at a variety of compressors. We're going to talk more about compressors in this video, and also we're going to do a separate video later of all the different types of compressors and go into detail about them. But right now, it's a compressor. It's also called a vapor pump. Now, that compressor does a few very important things. So the first thing that compressor does is it simply moves the refrigerant. It moves the refrigerant. So we're going to have a refrigeration cycle, and that compressor's job is to make sure we move that refrigerant. Without the compressor, the refrigerant's not moving. We're not having air conditioning. We're not moving heat from inside to outside. Nothing's going to be happening. So that compressor is easy to identify because it has wires going to it. Most of the time there's some kind of a motor there, and it's going to be moving the refrigerant. But also it has another job. Its job is to suck low pressure vapor. Suck, and I'm going to abbreviate LP for low pressure vapor. Some students find it better to write out low pressure, whatever works best for you, but that's a compressor, also called a vapor pump. It sucks in low pressure vapor and it pumps. And I'm going to abbreviate HP for high pressure vapor. So compressor sucks in low pressure vapor, pumps out high pressure vapor, it moves the refrigerant. So this compressor simply takes it from a low pressure to high pressure. And the reason is we want a high pressure, because when the pressure goes up, the temperature of the refrigerant is going to go up too. So as the temperature of that compressor goes up, the refrigerant is going to go up, and we want higher temperature refrigerant going through this condensing coil. I want to raise the temperature of this refrigerant higher than the air temperature, so heat will leave the condenser and go to the cooler air outside. So a compressor, vapor pump, moves refrigerant, sucks in low pressure vapor, pumps out high pressure vapor. Now the next thing that we have coming off, we're going to switch now to a red marker. Red is going to represent high pressure. We know that this compressor pumps out a high pressure vapor. In this particular model, it's pumping out the smaller line. It's pumping out high pressure. We're going to use red for high pressure. So high pressure is coming out. So I'm going to come out of my compressor with an arrow, and this red is going to represent high pressure. Now this line right here is going to connect it from the compressor to this condensing coil. It's the smallest line in the whole refrigeration system, but it's very, very important, and it has also 2 names. It is called a discharge line. A discharge line, but HVAC, everything has at least 2 names, so it's also called a hot gas line. Hot gas line. 2 names. The hottest part of that system is going to be right here coming out of the compressor. If you touch this line, it will literally burn you. It is hot. Hot, 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 hot. That's why we call it a hot gas line. And it's vapor coming into the compressor, vapor coming out. Vapor and gas can be interchanged many times, but that hot gas or high temperature, high pressure superheated vapor is very hot right here. What we're going to do is send that hot vapor to our next component. And we're going to add more words into this. We're going to be adding to this coil, so it's not done. Next, what I'm going to do is run my marker back and forth, back and forth, back and forth. Now, I've done this many times. Many students say that doesn't look like the unit at all, and I get that. My compressor doesn't look like a compressor at all. This doesn't look like a condensing unit at all, but the idea is you see these little tubes going back and forth, back and forth, back and forth on our coil. This is a small condensing coil out of a refrigeration system. I'm representing the refrigerant going back and forth, back and forth, back and forth through this condensing coil. This is where that second law of thermodynamics come into play. Heat's going to move from a warmer place in a refrigerant to the cooler place from the air outside. So heat's going to leave the refrigerant and go to the cooler air. Now that's really important. We also learned what affects the speed of the second law of thermodynamics, and that is surface area. So here we have a lot of surface area. We have a lot of aluminum, a lot of copper. There's going to be a lot of refrigerant touching a lot of metal touching a lot of air. And we have this fan on here, so we're going to be pulling air through it as well. So there's a whole lot of surface area. There's a lot of air touching a lot of this metal. And also the refrigerant is going to be a higher temperature than the air. So heat's going to want to move, and we also use aluminum and copper. This aluminum and copper allows us to transfer heat from the refrigerant to the cooler air. So second law of thermodynamics come into play right here on our condensing coil. And this condensing coil, in this case, is much larger than this. It's running around this whole entire section right here. So we're going into this condensing coil. There's a whole lot more steps we're going to add to this. But right now we're just going to simply learn that this is a condensing coil. Condensing coil. That's it. It's a condensing coil. So we go into the condensing coil as a hot gas. We're going to come out of this condensing coil, and we're still going to be red. This is where we're coming out of the coil, and we're going to have a very special line right here, and this line is going to be called a liquid line. And luckily, liquid line is the only line that we have one name for. So liquid line, it's fantastic. It's great. We're going to add more to this about the state of refrigerant in this line. It's very, very important. But to start off, it is a liquid line. So first major component we learned is compressor. Second major component is called a condensing coil. But we have a new component we're going to add next on this liquid line, and it is considered an accessory. It's a mandatory accessory in most cases, but it's still going to be called an accessory. And this accessory is going to be called a liquid line filter dryer. So our liquid line filter dryer looks something like this. It'll have an arrow on it, and we're wanting to send refrigerant away from the condenser, so we want our arrow pointing away from the condenser. There's many different kinds. This one's a solid desiccate type material, and it looks like a rock, but it still allows for refrigerant to flow through here. Refrigerant is going to flow on the outside section first, through this rock material and through the inside. And it filters the refrigerant and also pulls moisture out of the refrigerant. We don't want moisture in that system, but if there is, it'll pull moisture out. So another example of how they would look would be something like this. The refrigerant goes around that system, through the rock to the middle, and to the outside section. So we're going to draw that accessory here, and I found it extremely important that we learn where that is in the system, and it can be anywhere in the liquid line. I'm going to put it halfway, but we're going to use this in black because it's not changing anything. It's simply two names though: liquid line filter dryer. It's really all one name on this one. It's liquid line filter dryer. It's all one ginormous name, liquid line filter dryer. It has to go in the liquid line, and it's going to be a filter dryer. It's going to filter the refrigerant, and also it's going to pull moisture out of that. So we're going to continue our refrigerant into that filter dryer, out of that filter dryer, and we're going to come to our next component. And our next component is a key essential part, and it's drawn with simply a circle and an X through it. And this component is called our metering device. Again, we're going to go into more detail about all these components. This is our basic most refrigeration cycle, but this is our metering device. So I'm going to write over here metering device. Metering device. But in HVAC, everything has at least two names. So what we're going to do is add the second name. It's a metering device. It's also called an expansion device. That's a key word. We're going to talk about expansion later. It's super awesome. It's fantastic how it works. But we're going to call this metering device and also expansion device. Metering device and an expansion device. Let's take a look at what that would be. If we look on this coil, it's going to be back in the side. This is the fancy one. It's actually a thermostatic expansion valve. This is one example of several. We're going to go into all different types of metering devices, but this is a thermostatic expansion valve. But all of them are going to be an expansion valve. All of them are going to be a metering device. We have our liquid line coming in. We have our metering device in this example. And here we have multiple little lines coming out. These are called distribution tubes, and they're distributing refrigerant to multiple locations. We'll go into a little bit more detail about these two a little later on. But it's a metering device, also called an expansion device. And it has a few jobs here. One of the jobs is going to restrict or meter the flow of refrigerant. from a high pressure liquid to a low pressure saturated mixture. So we have high pressure liquids coming in and a low pressure refrigerants coming out. So we're having a massive pressure drop across this metering device. So it's going from high pressure on one side to low pressure on the other side. There's many kinds of these metering devices. We're going to go over those, but right now let's just learn it's a metering device, also called an expansion device, restricted from a high pressure liquid to a low pressure saturated mixture. And since we changed from a high pressure to a low pressure, we're now going to use blue. So pull out your blue, and again, we're going to now make a coil again. Just the circles back and forth, back and forth, back and forth, back and forth, etc., etc., etc. And this coil here is going to have a very special name, and this is called our evaporator. So we're going to write that word over here, evaporator. Evaporator coil, and here is our evaporator coil. Now notice that our metering device is located right up on our evaporator coil, so it's right there connected to it. So we drew it. Our metering device is right here next to our evaporator coil. So here our refrigerant is flowing through here, and our refrigerant is going to be low temperature. Low pressure is going to be absorbing heat. So we're going to absorb heat into our refrigerant. So as we absorb heat into our refrigerant, then we're going to connect our line from our evaporator all the way back to our compressor, and now we have a complete cycle. So we're going to be going into the liquid line through our metering device. It drops it to a low temperature, low pressure saturated mixture. Our refrigerant is going to be flowing through our evaporator coil. It's going to come out to this larger line. This line here has a special name also. It's called a suction line. It's also called a gas line. And the stated refrigerant line, we're going to be adding that to it, but we're going to have vapor coming all the way back to our compressor. So the big pipe here is going to be connected all the way to the big pipe on the outside unit, and we end up all the way to the bigger pipe going back into our compressor. So now we have a circle. Now there's many ways that we can draw the circle. Many different instructors draw it different ways. I specifically have it drawn this way for a reason, to prepare you for some future videos we're going to be doing. As you get this down, we're going to be adding tons and tons of information. What we need to do is make sure we add a few little notes over here. Let's add a note here so that we know that this is the outdoor unit. So we're going to write here outdoor. So we know that this is located outside. Notice our compressor is located right near a condensing coil. So we've drawn a compressor right next to a condensing coil. On this side, we have our metering device is right next to our evaporator coil, and here our metering device is right next to our evaporator coil. So this is going to be indoor. So outdoor coil and indoor. Indoor here, outdoor here. The other thing that we need to know is inside is doing what to heat. Is it absorbing heat or is it rejecting heat? Well, our refrigerant is going to be a lower temperature than the air. The heat's going to leave the warmer air, go to the cooler refrigerant, so it's going to be absorbing heat. So we're going to make a little note here on our evaporator coil. I'm going to put this in blue. The evaporator is absorbing heat. So here we're absorbing heat, and on the outside coil, we are rejecting heat. So we're going to put over here, rejecting heat. So rejecting heat. Absorbing heat from inside the house, rejecting heat outside the house. To absorb heat, my evaporator has to be a lower temperature than the air, so that heat leaves the air and goes to the cooler refrigerant. The outdoor unit has to be a warmer temperature than the air, so the heat leaves the refrigerant and goes to the cooler air outside. We don't cool a house, but we simply take the heat out of the house, and the temperature of the house drops. Let's go through a refrigeration cycle. This is the basic version. It's not enough. We're going to need to add lots more here, but memorize this, study this, use these vocabulary words, because we're going to be adding to this on that next video. So let's go through it real quick again. The compressor. Here's a compressor. It's also called a vapor pump. It sucks in low temperature, low pressure vapor, and it pumps out high temperature, high pressure vapor. This line is called a discharge line, also known as a hot gas line. The refrigerant leaves the compressor and goes into the condensing coil. This is outside. This is going to be rejecting heat. It's going to be warmer than the temperature of the air. Heat's leaving the refrigerant and going to the cooler air. Then we leave the condensing coil as a liquid line. We're going to go through our accessory, which is a liquid line filter dryer. That liquid line filter dryer can be anywhere from here, here, all the way over to here, but it's going to be in the liquid line. The liquid line is going to be the smaller 3/8 line. Our liquid line then goes to some sort of metering device, and our metering device has two names, also called an expansion device, which restricts it from a high pressure liquid into a low pressure saturated mixture. From there, we enter through all these little bitty tubes into our evaporator coil. The evaporator coil is now a lower temperature, lower pressure, and the temperature is below the air temperature, so heat leaves the air and goes to the cooler refrigerant. So from there, the refrigerant then flows through our suction gas line all the way back to the suction line here into the compressor. We now have our basic most level of the refrigeration cycle. So have this down. Now take this paper and go look at things. Go look at your house system. See if you can, now don't open up anything electrical. Don't open up, but look inside. See if you can see the compressor. See if you can see the condensing coil. Don't open up any panels unless you've gone through some OSHA training and understand safety, but take a look at where your lines are. See if you can identify it. Do a web search on some of these components. This is only the first level. We have a long ways set to go, but this is digestible. It's what I call the first plane or the first level. Once we get this level down, we're going to build on this. Just like this video built in the last video, the next video is going to build in this video. Before long, you're going to have a lot of questions now, but they're all going to be answered by the end of this series.